Good morning, students. I am Satarupa Satpathy and I will be taking your class on Introduction to Fuels, and this basically focuses on coal, its classification and analysis. Okay, so why are we studying fuels? Your program is on power plant familiarization. So here we have to take into consideration that what we all know from the first law of thermodynamics, that energy is cannot be created nor destroyed. So since energy cannot be created nor destroyed, so what we is available to us is we have to interconvert different forms of energy to get the form that is suitable for us. So here our ultimate aim is what? We need electrical energy. Okay, so this electrical energy, what is the main source of this in a thermal power plant? It is the source is the combustion reaction, that is of the fuel. Okay, so in fuel is a chemical compound, and so what is happening? The energy is stored in the fuel in the form of chemical bonds, that is in the form of chemical energy. So we have various, in a thermal power plant is a very complex place where you have various levels of interconversion. We just don't have conversion of directly from chemical energy to electrical energy, but there are various levels of conversion. Like, first thing is the fundamental energy releasing process in the thermal power plant is in the furnace, which is the combustion reaction. Here what is happening is the chemical energy that is stored in the fuel is getting released as heat energy in the furnace. Now this heat energy that is released in the furnace, this will be uptaken by water that is present inside my riser tubes inside the boiler, and this water will heat up and ultimately there will be a phase transfer of the water into steam. So what will happen now? This high pressurized steam, high temperature, high pressure steam, this has heat energy. The steam has uptaken heat energy. Now when the steam is being released from the nozzle into the turbine, what is happening? The heat energy that is inside the steam, this is getting converted into kinetic energy of the steam, which will be converted to kinetic energy of the turbine once the turbine starts rolling. Now this turbine is connected to the shaft. At the end of the shaft we have the alternator or the generator. So here what we have? Here we have a magnetic field, and when this shaft with its windings is rotating inside the magnetic field, what will happen? As we all know, there will be generation of electricity. Okay, electric energy will be generated. So we have so many conversions. That is, first is chemical energy to heat energy in the furnace, then from heat energy in the furnace to heat energy inside the water and steam. Then we have heat energy of water and steam to kinetic energy of steam, then kinetic energy of turbine and shaft. Then this ultimately gets converted to electrical power. Okay, electrical energy. So therefore, since the fundamental step in the thermal power generation is release of energy from the chemicals, so fuels have a very important role to play in the thermal power plant. Okay, so now we will go to what is actually a fuel. So what is fuel? A fuel, we can define a fuel as any substance that can be used to produce heat or power by combustion. So now what is combustion? Combustion is a special type of chemical process that is accompanied by the evolution of light and heat. Okay, that is basically, it is a reaction where a chemical substance is reacting with oxygen to release a huge amount of heat and light. Okay, so in the combustion reaction, therefore we will have fuel, and oxygen is must, and it will react together to form oxidized combustion products and release a huge amount of heat. Okay, so this is a fuel and combustion. So now we come to classification of fuels. So when we come to classification of fuels, so we can see fuels we can classify in two ways. Okay, first is based on the physical state. That means the physical state means whether the fuel is a solid fuel or a liquid fuel or a gaseous fuel. So example, it's very easy, like Solid fuel we can have examples of solid fuel are wood, coal, etc. Then for liquid fuel we can have different kinds of petroleum products. Okay, and gaseous fuels is natural gas, LPG, these are all gaseous fuels. The other classification is based on occurrence. On occurrence means whether we are using the fuel in the same form as we are obtaining it in nature, or whether the fuel is being transformed into some other form before we are using it. So we have a primary fuel or natural fuels. That means those fuels that we are using it in the same form as we are getting it in nature, they are called primary or natural fuels. Okay, like wood. When we are burning wood, we are not converting the wood into something else. That same wood is being burnt, right? Like coal. Coal, the way we are mining the coal, that same coal is being burnt in my thermal power plant. So there is no transformation between the extraction from nature and the end use. Okay, so these are primary fuels. The second is secondary fuels. Secondary fuels, or we can say prepared fuels or derived fuels. That means we are not using these fuels in the same way that we are obtaining them from nature. A very good example of this is petroleum products. Okay, for petroleum, what we are getting from below the surface of the earth is the crude oil. Okay, crude oil, if you see crude oil is a very thick, viscous, foul smelling liquid, and if you are trying to use crude oil directly, it's not going to help. So what is this done? This crude oil is sent to refineries. In refineries, what they are doing is they are basically thermally cracking it, that is breaking it down into smaller fragments, and then this is fractionally distillated and we get various fragments. We have, like after fractional distillation, we will get LPG, which is the gaseous part, then we will have the aviation fuel, then we will have the gasoline or the petrol that we call it, then comes kerosene, diesel. Ultimately what is left behind is naphtha and tar. Okay, so we have a lot of all these petroleum products are derived fuels. Okay, so that is the classification of fuels. So we have two bases of classification of fuels, that is, one is based on physical state, the other is based on occurrence. Okay, now we come to a very important part, that is characteristics of a good fuel. What will define a good fuel? A lot of substances react with oxygen to release it. Okay, but not everything is called a fuel. Okay, so now what is the characteristics that will define a good fuel? Like for example, let us say like coal. Coal is carbon, right? Graphite is also carbon. Graphite is rather more carbon than coal. If we call anthracite coal, which is the highest grade of coal, it's 90 to 95%, 96% carbon. Graphite is 100% carbon. Diamonds are also 100% carbon, but nobody calls graphite or diamonds a fuel. But coal is a fuel. Okay, so what is the characteristics that will determine what is a fuel and what is not a fuel, which is a better fuel, which is a poorer fuel? Okay, so let's look at the characteristics of a good fuel. So there are basically primarily 5 characteristics that we look into to determine the quality of the fuel. Okay, so first is ignitability. Okay, so ignitability means it should ignite easily. Okay, the temperature of the fuel, so what is, and ignite easily means there is something that is called the ignition temperature. For a fuel to be a good fuel, we basically, it should ignite easily, but again we should see that the ignition temperature is not very low. Okay, so now what is ignition temperature? Ignition temperature is basically the minimum amount of heat that should be provided to an air fuel mixture so that it starts burning, catches fire and continues burning. Okay, so once again, what is ignition temperature? It is the minimum temperature to which a fuel air mixture should be raised so that it catches fire and keeps on burning. Okay. So this is an ignition temperature. That is why we have that ignition switch in our automobiles, right? In the car, or we have to ignite it. That ignition has to start. Like coal, any fuel. Suppose let's take a certain amount of petroleum in a beaker, right? Petroleum and oxygen will react to produce combustion products, that is carbon dioxide, water vapor and heat. But if I am keeping it on the table, I'll keep it for 5 days, 6 days, 7 days, but it's not going to burn, right? So for it to burn, I have to give it that matchstick. I have to give it that ignition. I have to give it that spark, right? So that is what is the ignition temperature. Okay. So for a fuel to be a good fuel, this ignition temperature should be moderate. It should ignite easily, and the ignition temperature should be moderate. Okay, why moderate? Now if a fuel catches fire at a very low temperature, then what happens? The hazards, the risks associated with using that fuel increases. That is the problem with one of the major problems with hydrogen. Okay, hydrogen catches fire at a very low temperature, okay, around 70-80 degrees Celsius. So that is not very wanted. What we require is, it should not require a very high temperature, neither should it require a very low temperature. Okay, so for a fuel to be a good fuel, it should ignite easily. Then so here then we have what? It should have a high calorific value. What is calorific value of a fuel? Now calorific value of a fuel, we define it as, it is the total amount of heat that is released on complete combustion of unit mass of the fuel. Okay, that is any unit mass. It may be 1 gram, it may be 1 kg, it may be 1 metric tons, whatever be it. Okay, unit mass of the fuel is completely burned, and the total amount of heat energy that we are obtaining from it, that is called its calorific value. So what does it mean specifically? Higher the calorific value of the fuel, that means on burning unit amount of the fuel, we are getting more and more heat energy. So higher this heat energy value per unit mass of fuel, better will be the fuel. So a fuel should have a high calorific value. Okay. So now coming next. So we come to the third point. This is one of the most important points. The other 2 points are important, but this is also a very, very important point, that it should be inexpensive and readily available. Okay, you see, inexpensive and readily available. So what does inexpensive and readily available mean? Inexpensive and readily available means that the fuel should not cost very high. This is a very, very important factor in our economic operations. Okay, and easy availability. That is why in India, even if we look at the last financial year, not this financial year, even in the financial year that ended in 2018 to 2019, we look at the energy data, we will see that more than 85% of the total energy that was produced in the or used in the country came from coal-fired thermal power plants. Okay, the electrical energy. So, but ideally, if you look at coal has a lower calorific value, coal has a higher ignition temperature. Okay, so then coal has a lot of smoke and ash, okay, non-combustible material problem. So what happens is, this is a big problem, okay, but still we are using 80% of our power requirements are coming from coal. Why? Because its coal scores in this point, this third point, that is, it is inexpensive and readily available. Okay, that is, India has sufficient amount of coal reserves within itself, so that it can totally generate its own electricity based on coal. Okay, so this is a very, very important point. Okay, that the fuel should be inexpensive and readily available. Like we could have shifted to oil fired or gas fired thermal power plants. But the problem with oil or gas is India is not self-sufficient in oil and gas. So what will happen if we have to rely on some other country for oil and gas? First is we have to import it. So when we are importing it, we are losing out on foreign exchange. So it becomes expensive. Second is the security, power security of the state. What is by power security? What do we mean? By power security means, you see, power is the fundamental mainstay of your economy. Right? That means what? That means if you do not have power, you do not have an economy. Everything is running on power these days. Okay, everything from industries to your large scale transports like railways, then you have your commercial establishments, everything needs power to run. Without power, can you imagine this entire country without power? Everything comes to a standstill, right? So now if you are relying on some other country for your entire power needs, like suppose we go from, somebody says okay, coal is a very polluting source, so we will go from coal to oil. But this hasn't happened. Why? Because even though oil is cleaner burning, oil is does not produce ash, oil has more calorific value, but what we do is we are still using coal. Why? Because now if we have to use oil, we have to import it totally. Okay, now the country that is providing me with the oil can suddenly say, okay, I am going to stop supplying oil to you. And what happens? What will happen is, within a matter of a few days, the entire power generation inside the country will go down. It will stop. It will come to a standstill. And if power generation comes to a standstill, the entire economy comes to a standstill. Okay, so then what will happen? Entire economy comes to a standstill, and what will happen is, whatever that country will demand, we have to give it. So what happens? We will compromise on the security of the country. Okay, so this third point is very, very important, that it should be inexpensive and readily available. Okay, the fourth point is it should be easy to store and transport. Okay, storage and transportation of the fuel should be easy, and that will provide another economic benefit. And lastly, it should have low smoke and non-combustible matter. By non-combustible matter, what we mean? The material inside the fuel that does not burn. Okay, because you are obtaining it from nature, so there will be some parts that will not burn. So this is called the non-combustible material. Basically, by that we mean the ash. Okay, so in these mainly this coal will score low in this point. Coal will produce a lot of smoke. Coal will also produce a lot of ash after burning. Okay, so this ash becomes a disposal problem. But anyway, so these are the 5 characteristics of a good fuel. So first, number 1 is it should have a moderate ignition temperature. Number 2 is it should have a high calorific value. Number 3 is it should be inexpensive and readily available. Number 4 is easy to store and transport. And number 5 is low smoke and ash. Okay. So now we will come to, so these are the basic introductions of fuel. So now we will come to what? We will come to the next part, that is we will see what is coal. Now what is coal? So coal is basically a stored fossil fuel occurring in layers in the earth's crust, which has been formed by the partial decay of plant materials accumulated millions of years ago and altered by the action of heat and pressure. So why do we call coal a fossil fuel? Because it is a transformed part of a living organism. Okay, that is, coal has been formed from prehistoric plant material which were transformed underground by the action of heat and pressure. Okay. So now first then we will look into Okay, so now we look at coal formation. How this coal was formed. So initially what happened millions of years ago when the earth was very swampy, okay, we had the earth was covered with large vegetation, huge vegetations. What happened? These plants died and they were buried under the water. Okay, so this is very important because they got buried under water, otherwise would not have coal. So they got buried underwater. Underwater, what happens? Your oxygen supply is limited. So when your oxygen supply is limited, what will happen is this plant materials were not decomposed completely. And now what happened with these partially decomposed plant material, they got accumulated in under the soil. Okay, this partially decomposed plant material that is accumulated under the soil, this is called peat. This is the first step in the formation of coal. Peat is not coal, mind you. Peat is just a precursor to coal, the first step from plants to coal. Okay, so now what happened, as time went by, what happened due to movements of the earth plates on the earth's surface, this peat got buried deeper and deeper. As it went down, what happened? We had the action of heat and pressure acting upon this partially decomposed plant material, and they converted first to lignite. Lignite is also not a proper coal, even though we sometimes consider it as coal. Ideally, lignite is not considered proper coal. Okay, it is again a precursor to coal, but lignite is, peat is hard. So with further time and pressure and heat acting on it, what happened? This lignite slowly converted into coal. Okay. So we now come to what is the composition of coal. So composition of coal, if we look, coal is mostly carbon, more than 50% of it is carbon, along with some other impurities like volatile matter, sulfur, some trace amounts of chlorine, phosphorus, nitrogen, trace amounts of oxygen and other elements. Okay, so this is what coal is basically composed of. Now we come to classification of coal. So classification of coal. So why was there a necessity to classify coal? Necessity to classify coal means coal is a very loose term. Okay, it covers a wide variety of substances with varying compositions. If we have different kinds of coal, like even if I leave out lignite, we will have various kinds of coal. Okay, like we have subbituminous coal, we have bituminous coal. Bituminous coal, again we will have several grades of bituminous coal, like we have long flame bituminous, short flame bituminous. Okay, so then we have anthracitic coal. So what happened? Initially when coal was used, there was no classification. But as the demand and trade in coal increased, what happened? People found out that, okay, this particular coal is providing me with more heat, less smoke. That particular coal is producing a lot of smoke and providing less heat. So what happened? Slowly, as the demand and trade in coal increased, what happened? People realized the fact that we have to grade the coal. That is, we have to find out which coal is better, which coal is poor. This gradation has to be done. Okay, that is there for all kinds of products, right? When we are using any product from the market, what happens? After some time we try. Okay, this product is better. Okay, this product is a little less. So same, like if we go to the market to buy shampoos, we have a wide range of shampoos, right? And a wide pricing to them, right? Why does somebody buy a more expensive shampoo? Probably because they find that this brand is suiting them more. Okay, so same thing for coal. When the demand and trade in coal increased, people felt the need to classify or grade the coal. Okay, so therefore the needs for classification were variable characteristics of coal, different boiler furnaces in use. Different furnaces could use different kinds of coal, applications in chemical technology and metallurgy, and extended trade. Due to this, what happened? We had a requirement for classification. Now we very broadly, coal can be classified in many forms. We have various categories of classification, but very broadly let's go into the different types of coal and broad classifications. So first we come to peat. So peat, as I told you, peat is an accumulation of partially decayed vegetation matter and is the first stage in the formation of coal. Okay, so peat if you mostly find in wetlands, okay, at the bottom of, even in bottom of lakes. If you go to cold countries, below the surface of the earth you can find an accumulation of peat, because in cold countries what is happening, the temperature is very low. In the Scandinavian countries like Norway, Sweden, Finland, then like in Scotland where it is very cold throughout the year, what you can get is the grass and the herbs that are growing, they get buried under the soil and they are partially decomposed, and this accumulation basically keeps on accumulating, and this is peat. Okay, in tropical countries like India, you are not going to get peat under the soil, but you can get some amount of peat at the bottom of ponds and lakes which do not dry up. Okay, so peat is this partially decomposed vegetative matter, and it contains a huge amount of water and moisture in it, and it should be dried before use. In many of these very cold countries, the village people, they basically mine, dig for peat. Okay, it burns with a lot of smoke. Okay, so here you see, here is a picture of how they mine for, they dig for peat. Just under the soil you can get peat like this, and you see this is a very, you look at this picture, you will see that it is partially decomposed. You can find out bits of, you can sticks, roots, these can still be seen. Okay, so this is the first step in the formation of coal, and that is called peat. Okay, now we come to lignite. So now what has happened, this peat was buried deep into the ground due to activity, plate activities. Plate activities means when we are having the earth surface moves, right? Earth surface is not a whole surface, right? It's formed of different, like fitted like jigsaw puzzles, okay, small plates, and they can move relative to each other. One can go below the other. So when these activities took place, what happened, the peat got buried deeper and deeper into the earth's surface. So as it went down, what happened, as we go down the earth's crust, what happens, we have an increase in temperature and pressure. So this peat was now subjected to heat and pressure. Okay, one thing you have to keep in mind here is, that is, the process of formation of coal does not happen over just years or over centuries. It takes millions, hundreds of millions of years. Like the coal that we are mining today was formed from plants that grew 300 million years ago. Okay, so that is why coal is a non-renewable resource, because the process of formation of coal will take hundreds of millions of years. Okay, it's not that it will form in overnight, or it will form in a span of 50 years or 100 years or 1000 years. It will take hundreds of millions of years. Okay, so now what happened, slowly this peat went down and it was subjected to heat and pressure, and what happened, it was transformed in, it gets transformed into lignite. Lignite is often known as brown coal. So in lignite, it is a very soft coal. Okay, very soft means you can basically break open lignite with your hands. Along the plains it will break open. Okay, it has a very high inherent moisture, and sometimes it may be, this moisture percentage may be as high as 66%, and very high ash content compared to bituminous coal. Now lignite, you see, that is why lignite is called brown coals, from reddish brown to dark brown. Okay, the color will vary. Lignite is basically, lignite is used today, lignite, but what happens is, lignite has no transport value. Lignite is used in situ. In situ means the place where lignite is mined and where it is used is side by side, because the heating value of lignite is so low. If you have to transport the lignite over a distance, it basically does not pay. So in India, like you have lignite fields in Neyveli in Tamil Nadu, So there Neyveli Lignite Limited and Neyveli Power Limited, they are just side by side. Okay, they are mining the lignite from the lignite fields and simply sending it over to the power plant next door. Okay, so lignite has so low heating value that it does not basically pay to transport lignite over long distances. So now we come to bituminous coal. Bituminous coal is the third stage of coal formation, and bituminous or from subbituminous onwards we call it proper coal. Okay, so now this lignite that was there, it was subjected to even more time and pressure and heat, and what happened, and all trace became very compact and all traces of plant life disappeared. Okay, it is a higher quality than lignite coal but poorer than anthracite. Okay, this is the most widely available subbituminous and bituminous. This is the most widely available variety of coal, and it is mostly used in the industry. So here if you look, you see this structure has become more compact. Like if you look back at the lignite you see there is a woody texture to it, but if you look at this bituminous coal, you see there is a shiny crystalline structure to it. So what has happened, the plant traces of the plant material that was totally removed. Okay, that this is a plant material, you cannot distinguish it any further. So there is a shiny texture to it. It's usually dark brown or black or dark gray in color. Okay, it is harder, okay, then you cannot break it with your hands. You need a hammer to break it open. And bituminous it is called because it contains a tar like substance called bitumen. Like if you go for destructive distillation of the coal, that is the coal destructive distillation means we will heat the coal in the absence of what we call in the absence of air, then what will happen, a tar like substance which is called bitumen is formed. Okay, now we come to the anthracite. This is the best variety of coal that is available. Anthracite is only about 1% of the total coal deposits in the world is anthracite. Okay, so this is the fourth and final stage in the formation of coal. So it has a very high carbon value, very low moisture. So carbon value is above 90%, 90 to 98% carbon you have, and higher hardness, greater density, and burns more efficiently. Its calorific value is highest among all the varieties of coal, and smoke is almost nil. Formation of smoke is almost nil. Formation of ash is also very low. Okay, so this is anthracite. So now I would like to tell you one thing, a very interesting fact about anthracite. So after anthracite, when this anthracite is subjected to more temperature and heat, what will form? It will go into the graphite form. Graphite is no longer a fuel. Okay, so one very interesting fact about anthracite is, anthracite, one of the first known uses of anthracite by humans, okay, archaeology is as jewelry. Okay, archaeologists have uncovered prehistoric sites, 3000 to 4000 year old archaeological sites, where they have discovered jewelry items made of anthracitic coal. So why did people make jewelry out of anthracitic coal? Because anthracitic coal is very, very shiny. So let's look how anthracite coal looks like. Anthracitic coal is very, very shiny in nature, very hard, very dense, burns without smoke, but its ignition temperature is higher. So it can be polished. This is another reason why coal is called black diamond. Okay, diamond is also carbon, coal is also carbon, but the shine of anthracitic coal is the reason why coal is called black diamond. Okay, so we have the Black Diamond Express in these Black Diamond Express that runs from Kolkata. So why is it called black diamond? Because very earlier during the British times, anthracitic coal was mined in the Raniganj coal fields. Okay, now you no longer have anthracitic coal there, but Raniganj coal fields at one time during the British rule produced very high grade anthracitic coal. So now we look at the fuel efficiency. So in this diagram you can see here we have the heating value and here we are having the percentage carbon. So from lignite to anthracite, what happens? We see the percentage carbon is increasing. You see the percentage carbon increases, and as the percentage carbon is increasing, we have an increase in the heating value. Here the heating value is given in British thermal units per pound. So same way, any unit you are using, you will see that the heating value increases up to anthracite. But beyond anthracite, when it goes towards graphite, you will see there is a drop in the heating value. Why is there a drop in the heating value? That is because now what will happen, the beyond anthracite, the structure of carbon, when it goes into graphite, it becomes so stable, you will require a very high temperature to break the carbon-carbon bonds. So as a result, what happens, the total amount of heat that is released will reduce. Okay, your input heat amount will increase greatly, so your output heat amount will decrease. Okay. So now that was up to the classification of coal. So now we will learn a little about the analysis of coal. In a thermal power plant, basically, since you have to run your power plant on a particular load, okay, based on your grid. Now we all have grid connected plants that are directly connected to the grid. We do not have individual plants. Okay, so all plants are directly connected to the grid, and based upon your grid load, you have to run your plant. So when you have to run your plant at a specific load, suppose you are running your plant at a 250 megawatt loading. Okay, so when you are running it at 250 megawatt loading, you have to make exact calculations, right? To generate 250 megawatts of power, how much amount of turbine power I am going to need? For that turbine power, how much amount of steam I am going to need? How much steam? To prepare that amount of steam, how much amount of heat is required? To get that amount of heat, how much amount of coal I have to burn? So since we have to calculate the amount of coal that is required, and all coal is not same. Even if you have coal of the same lot from the same mine, you will find there are differences. Okay, so therefore it is very important to analyze the coal. Coal analysis is very important, and all power plants will come with a coal analysis lab. Okay, where every day they are analyzing the coal and sending the report to the control room, based upon which they are altering the coal flow, altering the air flow, so that they can optimize the power generation. So analysis of coal, when we look at it, we have basically three main types of analysis. One is proximate analysis, ultimate analysis, and heating or calorific value of coal. So first, coming to proximate analysis. So what is proximate analysis? Proximate analysis, the word proximate comes from the word approximate. This was one of the first tests that were done for coal, gradation of coal, and during that time we did not basically determine each element individually. Okay, some parameters were taken, and based on these parameters we made a rough evaluation of what was the grade of coal. Okay, these tests are still done because they are very relevant. Okay, in proximate analysis, basically we are doing 4 tests, and what are these 4 tests? We are doing, first is moisture content, second we are doing volatile matter content, third is fixed carbon content, and ash content. Okay, so basically we test for 3 parameters, that is total moisture, volatile matter, ash, and fixed carbon. We find out by difference method. Okay, so the total coal testing, this is guided by, in India is done by the IS standards, BIS standards, and the standard is IS 13501 1984. This standard was first evolved in 1984. After 1984 we have several modifications, but still the main standard is IS 13501 1984. Okay, 1984. So therefore now we look into the parameters that is covered under proximate analysis. So first is moisture. Okay, so lesser the moisture content, better is the quality of the coal. Okay, so how is moisture content? Because moisture, what will happen in moisture is, well, when this moisture in the coal is present, and if we try to, when this coal is being heated in the furnace or burnt in the furnace, what will happen? Water has a very high latent heat of vaporization. Okay, this moisture will absorb heat and carry it, convert to steam, and this will move out with the flue gases. That means what is happening? The water is converting to water vapor. When it converts to water vapor, it is absorbing the latent heat of vaporization from the furnace. So a large part of the heat is going into the moisture. So higher the moisture content of the coal, lesser will be the useful heat value of the that you are obtaining in the furnace. That is, the moisture will take the water, moisture will take your heat and move out. So that amount of heat is lost to you. You cannot use that heat. So the useful heat means the heat that will be available for use in the furnace, this amount will reduce. Okay, so therefore it is very important to do the moisture analysis. Okay, so here what we do, the moisture analysis is done by placing a sample of powdered raw coal and heating it in an oven kept at 105 plus minus 2 degrees Celsius with the lid for 1 hour. Then it is cooled, the loss in weight is taken, and we can calculate the percentage moisture. Percentage moisture is loss in weight by weight of coal taken into 100. Okay. Then we come to, when this measurement of moisture is done, like if you have ever gone to a thermal power plant, you will see that coal is stored in the coal yard. Coal yard means it's nothing, it's on the open ground, huge stacks of coal is kept. Okay, so since it's stored outdoors, what happens is, when it will rain, this rainwater comes into it. So there is two kinds of moisture in coal. One we call the external moisture, that is the moisture that is picked up by the coal by exposure to atmosphere. Okay, other is inherent moisture. Inherent moisture is the moisture that is chemically associated with the structure of the coal. So please remember that when we are referring to moisture percentage in coal, we are not referring to the external moisture. The external moisture is not estimated. The coal is dried, air dried before the moisture estimation is done, so that the external moisture is removed from it, because the external moisture does not enter my furnace. Okay, only the thing that affects the useful heat in the furnace is the inherent moisture or the chemical moisture of the coal. Okay, so whatever value we are receiving in proximate analysis is the inherent moisture of the coal or the water that is associated chemically with the structure of the coal. Now we come to measurement of volatile matter. So measurement of volatile matter, what is volatile matter? Volatile matter is, when will heat the coal, what happens, some amount of smaller hydrocarbons, which are mostly in the form of gases, okay, are sticking to the surface of the coal. Okay, not only the surface, even inside the pockets of coal will contain small amounts of hydrocarbons that is sticking to the coal. So when we first heat the coal, what happens is volatile matter comes out. So we have to measure this volatile matter. Okay, so volatile matter, what we do, fresh sample of crushed coal, we take it and it is placed in a covered crucible and heated in a furnace. So this particular furnace is called a muffle furnace at 900 plus minus 15 degrees Celsius for exactly 7 minutes. Okay, covered coal sample, we are heating at 900 plus minus 15 degrees Celsius for exactly 7 minutes, after which it is removed from the furnace, cooled and weighed. The loss of weight represents the volatile matter. Okay, now we come to measurement of ash. So measurement of ash, now what is ash? Is the, I said earlier that ash is the non-combustible part of the coal. That is, in the coal we will have some materials which does not burn or react with oxygen to produce heat and energy. Okay, so this is the ash. So for measurement of ash, what we do is, we simply take a certain amount of coal and measured amount of coal, and we simply burn it in air. Okay, we heat it till all the carbon is burned, and then it is that is in an open crucible for 800 at 800 degrees Celsius for 1 to 2 hours. Then the residue is weighed, that is whatever the residue, the carbon whatever was combustible has turned into carbon dioxide and water vapor and moved out. Okay, and whatever is left, solid portion that is left behind after the burning, that is the ash. Now this residue that is left behind, that is weighed, and from that we find out the weight of the ash. So now we come to measurement of fixed carbon. Okay, so measurement of fixed carbon, this we do not do any, we don't have to do any particular test. It is found out by subtracting. That is, I have found out the percentage moisture, I have found out the percentage volatile matter, I have found out the percentage ash, right? So now what we do is, we will simply do 100 minus percentage moisture minus percentage volatile matter minus percentage ash, and whatever is result we get, that is reported as the fixed carbon. Okay, so this is how we do fixed carbon. Okay, fixed carbon percentage 100 minus moisture plus volatile matter plus ash percentage. Okay, we don't have to do any tests for it. Okay, now let's see, here is a table. In this table we can see the comparison of proximity analysis of different kinds of coal. We have Indian coal, Indonesian coal and South African coal. So if you look at Indian coal, one of the major disadvantages of Indian coal is that it basically has very high ash content. If you look at this ash content, you see Indonesian coal, in this they have 13, 14 or 17%, but in Indian coal our average ash content in Indian coal varies between 30 to 40%. Even sometimes we even get coals that have 45% ash. Okay, now we come to the significance of the various parameters in proximity analysis. So first is fixed carbon. So main thing about fixed carbon is, since this is the carbon portion, what happens is, so more the carbon, more will be the heat energy released. So higher the fixed carbon value, more is the heating value of the coal. Okay, then we come to volatile matter. Volatile matters are mostly, as I said these are smaller hydrocarbons, methane, hydrogen, carbon monoxide, and some trace amounts of incombustible gases also. But the main thing is, most of the volatile matter is combustible. And what happens is, when the coal first catches fire, the volatile matter will burn at a lower temperature. Okay, so when we have high volatile matter, what happens? It reduces your ignition temperature of the coal. Okay, and more volatile matter will mean that it will increase your flame length. Okay, so if your flame length increases, and more volatile matter will therefore mean your ignition temperature is lowering and your flame length is increasing. So if you have a higher flame length, you are using coal that has more volatile matter, that means you have to provide more furnace volume for the combustion process. Okay, now we come to ash content. So ash content is, so ash is an impurity, is not going to burn. So what is the impact of ash? First is, it will reduce handling and burning capacity. It will reduce your burning capacity. That means you are putting in 100 kgs of coal, and if 40 kgs in that is ash, that means 40 kg of it is simply unwanted material, but you cannot remove it. Okay, it increases handling costs, affects combustion efficiency. So combustion efficiency will be reduced. You are putting in 100 kgs of fuel, but what you are actually getting is actually 60 kgs of fuel. So your burning efficiency is decreasing. It will cause clinkering and slagging. By clinkering and slagging, what do we mean? Clinkering means, inside the furnace what happens? The ash tends to melt, and that is called slagging. And what happens is, it will cause, and then it solidifies into stones. Okay, so it will basically melt, that is called slagging, and it can solidify into stones, which is called clinkering. So if you have slagging and clinkering, it can cause a lot of problems inside your furnace. Okay, now moisture I already told you that moisture is basically, it increases the heat loss. Okay, but however there is another plus point to moisture, it helps to reduce explosions inside your furnace. Okay, now we come to the ultimate analysis. Ultimate analysis is a very improved analysis. Here we are basically estimating the exact percentages of certain elements present in the core. Okay, ultimate analysis is very important in today's in terms of today's context of power generation, because now the power generation system is highly fine tuned. Okay, so unless only proximate analysis is not going to help us. We have to know exactly the amount of carbon, hydrogen, sulfur, oxygen that is present in the coal. Only then we will be able to estimate exactly how much amount of coal we have to burn in the furnace. Okay, per minute. Okay, how much amount of coal charging, coal flow, air flow, all these will be determined. Okay, so ultimate analysis is very important. In ultimate analysis, what we are doing is, we do the analysis of percentage carbon, percentage hydrogen, percentage oxygen, percentage sulfur, and another very important that is ash. These 5 are the most important analysis that we do in ultimate analysis. However, ultimate analysis we can expand it to include the entire element profile, because in coal, since it is found under the earth's surface, most elements will be found in trace amounts. Okay, but the must analysis are in ultimate analysis: percentage carbon, percentage hydrogen, percentage oxygen, percentage sulfur, percentage nitrogen, and percentage ash. Okay, and this is required for calculation of flame temperature, flue duct design, calculation of quantity of air that is required for combustion, all these. Okay, it is very important. Okay, so now I am not going into the details of ultimate analysis, how we do them, but we will look into the significance of the ultimate analysis. So greater the percentage of carbon and hydrogen, better is the quality of the coal and higher is the calorific value. Okay, nitrogen has no calorific value, hence its presence in coal is undesirable, and good quality coal will have very little nitrogen content. Okay, sulfur is mainly contributes to heating value. Okay, so if you have sulfur in coal, it will contribute to the heating value, but another disadvantage is it will produce sulfur dioxide. Sulfur dioxide means it's an acidic gas. It will cause acid rain and pollution, or atmospheric pollution. Okay, and it will also, since it is acidic gas, it will cause corrosion in the equipments. Okay, so sulfur we have to know because of these facts. Oxygen content decreases the calorific value of coal. Again, high oxygen contents are characterized by high inherent moisture content. So that will mean low calorific value and low coking power. Okay. So these, and ash content, that's the same as in proximate analysis. So here you see, here this is a analysis, typical ultimate analysis. Again, a comparison is done between Indian coal and Indonesian coal. So here earlier I had said during proximate analysis that one of the disadvantages of Indian coal was it had very high ash, but Indian coal has another advantage, that is sulfur content in Indian coal is lesser compared to other coals. Okay. Now we come to determination of the heating value of coal. So heating value of coal, or determination of what we call the calorific value of coal, this is also done in the labs beside proximate analysis and ultimate analysis. So here what we have two kinds of calorific value. One is called the GCV, or the gross calorific value, and the other is the NCV or the net calorific value. Now what is GCV, what is NCV? So GCV is basically defined as the total amount of heat released on complete combustion of unit mass of fuel. Okay, total amount of heat that will be released on complete combustion of unit mass of fuel, that is called your gross calorific value. Okay, and net calorific value is, it is the total amount of useful heat released in the furnace. It is not total heat, please keep in mind, it is the useful heat released in the furnace. What is the difference between this total amount of heat and useful amount of heat? Here it is that moisture plays the important role. Okay, that means what I said earlier is that if we have moisture in the coal, and this moisture will absorb the latent heat of vaporization and move out with the flue gas, and this heat is lost. Okay, so basically NCV is your GCV minus heat loss due to water vapor. Okay, so this is your difference. So GCV, basically in the lab we determine the GCV, and the NCV we will basically what we do is NCV is calculated using certain formula. Okay, so GCV is determined, that is the total heat value is determined, but the GCV is of no use to us inside the furnace, because that amount of heat will not be available inside the furnace. What we will the available amount of heat inside the furnace will be the NCV, or sometimes we call it the greater heating value and the lower heating value. The GCV is the greater heating value, NCV is the lower or lesser heating value. Okay, so GCV minus heat carried out, heat lost by moisture, is your NCV. This amount of heat is actually available for uptake by your water in the boiler. Okay. So now we will come to grading of Indian coal. So Indian coal is graded. We have various grades: coking coal and non-coking coal. First is, so coking coal is any coal that will have carbon percentage greater than 81%. Okay, greater than 80%, that is called coking coal. So what is coking coal? Coke is basically when we are heating coal in the absence of air. What will happen? All the volatile matter impurities are driven off from it, and a solid carbon residue is left behind. This is called coke. This is a very pure form of carbon, and this is basically what is used as a reducing agent in metallurgical industries, like in steel plants. Steel plants, what is happening? We are using iron oxide as the ore, raw material, right? From this iron oxide we have to get the iron. So what is happening? This iron oxide reacts with carbon. Carbon basically removes your oxygen, and we are getting the metallic iron. Okay, so here what happens, we require in metallurgical industries, we will require very high grade carbon, because if you are otherwise you are using low grade carbon, what will happen? Impurities will come into your metal. So high grade carbon is used. So in throughout the world, we use the high grade carbon coals. They are called manufacturing coals. Okay, most of the high grade coals, they go into the manufacturing industry, where you require high grade carbon to reduce the impurities in your metals. Okay, so that is coking coal, and the rest is, if you have less than 80% carbon, that is called non-coking coal. Okay, so you see grade 1, this is used in the steel industry. Grade 1 and 2, this is used in the steel industry, that is, it should have ash less than 20%. Okay, then you can have washery grade. Okay, so steel grade 1, steel grade 2, then you have washery grade 1, 2, 3, 4. Washery grade means the coal is washed to remove a certain percentage of its ash. Okay, so that some of the impurities from the coal can be removed. Okay, we have coal washeries, and usually if we go for the supercritical power plants, it is very important that we have washery grade coal. Okay, and this is based upon grades of non-coking coal. So non-coking coal, if we look, this will have high ash content, lower heating and calorific value, inferior quality, and this is suitable for power generation. So usually what happens is, mostly for the power industry, we have D, E, F, G, these are available for the power industry. Okay, because here anything that will burn will go, and so high grade coals, they will go exclusively to the manufacturing industries, whereas the poorer grades of coal gets used in the thermal power plants. Okay, so I think that was a lot on coal, fuels and classification analysis. So I don't know how much of it you were able to assimilate. So in case you have any questions, please feel free to contact me at the given email and WhatsApp number. Okay, thank you so much.